This is a classic example where they want us to find the area of the region enclosed by two given curves. So in this situation, y equals x to the fourth and y equals 8x. I will tell you this, the better you know your families of graphs, your standard equations going into a test, the happier you will be because you want to kind of have a sense of what these graphs look like. Because on problems like the one we're looking at right now, they're not letting us use a calculator on it. And so what that means is we either need to know what these graphs look like and are able to tell what's going on, or we're going to have to do some additional work. The reason that we need to know what's going on is because of our formula we use for finding the area of the region enclosed by two curves. The general formula for this looks like the integral from a to b, and I just call it whichever equation is on top minus in parentheses whichever equation is on bottom for that region. So top meaning above, bottom meaning below. When we talk about the A and the B, our bounds here are generally going to be the intersect of those two graphs because that'll squeeze together and close off the interval. Some problems give you their own bounds to close these things off. A lot of times, though, you're going to have to go find them for yourself. So, if you don't know already, y equals x to the fourth would be a graph that looks like this, right? And then y equals 8x would be a graph that kind of cuts across like this. So a straight line with 0 as the y-intercept right there. You may not know that though. Like I know that, but you may not know that. And so when we go to do a problem like this, to see which one's on top and which one's on bottom when we don't necessarily know our families of graphs, this is what we'd have to do some additional work. So the first thing we want to do is we want to kind of find where are these intersects? Where are these two graphs going to run into each other? So to find where they intersect, that's where you just take the two equations and you're going to set them equal to each other. Wherever those two equations are equal or where they run into each other, and that's going to be where our bounds end up becoming. So to solve a problem like this, whenever you've got a power of 2 or greater, the method is always the same. You want to get this thing set equal to 0 and then factor it. So minus 8x minus 8x, we end up with x to the fourth minus 8x equals 0. So there's the setting it equal to 0 part. And now the next piece is to go ahead and factor this. The first thing we can see is we've got kind of the nice straightforward factoring here where we just have an x that's in both pieces. So we pull the x to the front, and that's going to leave us with x cubed on the first piece minus 8 on the second. The reason we do this is now that these two things are being multiplied, we can break it into two smaller bite-sized problems. So whenever we take and set those equal to 0, so whenever x equals 0, we know we've got something happening there. And then whenever x cubed minus 8 equals 0, we know we've got an intersect there. Well, the x equals 0 piece is done. We need to just finish up solving this other equation to get our x. So we add 8, we end up with x cubed equals 8. And then we go ahead and cube root both sides of this. And that's going to end up with x equals 2. So those are our two intersects. So, again, if you know your graph, it's easy to kind of tell that that's 0 and that's 2 going on right there. But again, we're kind of playing this out as if you don't know what those graphs look like. So right now, you know that that is the bounded region, right? That between 0 and 2 are where these graphs are going to be. However, you don't know which one is on top and which one's on bottom. So what you're going to need to do is you're going to need to choose a test value inside that region. I'm going to choose x equals 1 because it's a simple number to do math with. So we take our test value and we plug that value into our equations. And we see what those y values are that come out of there. So when I plug in 1, I get out 1. And then when I go to the next equation, when I plug 1 into 8x, y equals 8 times 1 equals 8. So these are the y values right now. And so what that's telling me is in that little region right there, that 1 is below, it is the smaller number, and that means that the 8 is above. So what we're getting out of here is the fact that the top equation is going to be the 8x, and the bottom equation is going to be the x to the fourth. We essentially found this point right here where we could see that this point is above that other point. Once you know your bounds and you know which one is on top and which one's on bottom, now it just becomes a process of doing a definite integral. So you come through and set up your definite integral. Our definite integral would go the integral from 0 to 2 of the equation that was on top, which we found to be 8x, minus the equation that's on bottom, which we found was x to the fourth. Always put the bottom equation in parentheses just as a habit, because sometimes this one, it's not a big deal because it's just x to the fourth right here. But if there was more going on, we would need to distribute this negative sign back through all of those pieces. And so that's why putting your parentheses around that bottom equation will always save you in the end. So rewriting this, dropping the parentheses, simplifying it down, we're looking at this, 8x minus x to the fourth. And now we just do our power rule. So we are going to add 1 to the power. There's an unwritten 1 right there. So we add 1 to the power, divide by the new power, minus add 1 to the power gets us x to the fifth over 5. And then because we have bounds, we say evaluated from x equals 0 to x equals 2. And so from there, we're now just going to go ahead and we do, again, this whole section is really all top minus bottom, kind of keep that in mind. We're going to take our top value, plug it into that equation, and now subtract off the bottom value. So we could actually simplify this down a little bit. The 4 and the 2 will cancel. So we get 4 times, in parentheses, 2 squared minus 2 to the fifth over 5. That's our top value minus our bottom value. And so we should end up, we get 4 times 0 squared minus 0 to the fifth over 5. And when we plug all that into our calculator, we would end up, or do it by hand, you would end up with 48 over 5. So the area of the region bounded by these two graphs, essentially this area that I'm shading in right here, is 48 over 5. And keep in mind that when you are doing this area between two curves styles of problems, your answer should always be positive. An area between two curves is always a positive thing. It's never a negative thing. So if you got out a negative number when you're doing a problem like this, you know you messed up someplace. Here we got out the positive like we were hoping for, and so we were able to find the area of the region bounded by the curves y equals x to the fourth and y equals 8x. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.